Welcome to section 12, and in this particular section we're going to take a look at adding identity into our application. And let's take a look at the learning goals for this section. So we're going to be adding ASP.NET Core Identity. This is a battle-hardened, fully tested, off-the-shelf identity package that comes with our .NET SDK and runtime, and we're going to implement this into our application. Now, the type of authentication that we're going to be using in our application, because we're using an API, then it's typical to use JSON Web Token authentication, or JWT token authentication with this kind of application. And we'll take a look at JWT tokens as and when we implement them a bit later on. So we're going to be implementing a login and register, give our users the ability to do both of those things, and we're going to authenticate our requests. As at the moment we simply don't have any authentication, everything's available to anonymous users. So let's just take a look at some of the features of ASP.NET Core Identity. Well, it's a membership system and it supports logins stored in identity. So our users are going to be able to log in and they're going to be stored in our database. It also offers support for external providers. And later on in the course, we'll take a look at adding Facebook authentication as an example of using an external provider with identity. It also comes with default user stores. So when we add this and we add the identity entity framework package, then this is going to provide us with a bunch of stores or tables that get added to our database. So we're going to be creating an entity that we get from ASP.NET Core Identity Entity Framework, and this is going to create a bunch of tables in our database just by us configuring this and adding a single entity. It also comes with a couple of managers. It gives us a user manager and a sign-in manager, and the user manager, well, it's going to be used to manage our users. So if we want to create a user, we want to get or find a user, then we'll use the user manager. And we're going to be storing the user's hashed password in a database, and we're going to be using the sign-in manager to take the user's password as a string and then compare it with what's stored in our database. Now, storing passwords in the database sounds a bit scary, but it really isn't. And the ASP.NET Identity stores a hashed version of the password in the database, and it also adds salting to the database as well. Now, password hashing is a one-way operation. You can only hash something, you can't dehash something. But it's very easy to work out a password that's just been hashed because every possible string combination has already been hashed in advance, and there's dictionary tables that you can go and look up to find the non-hashed version of a particular password. So that's where salting comes into it. It adds a randomized element to the hash, and each time we salt a hashed password, then it becomes more and more difficult to get the unhashed version of that password. So let's take Sally and Bob in this example. They're both registering to our application, and coincidentally, they're both using the same pretty weak password, a password that's commonly used in training courses such as this one. Now, when they register their user and they send these details to our application, then this password is going to be hashed and it's going to be salted. And when we store the password in our database, then it's going to be a hashed version of this that's been salted many times. So even though the passwords are identical, in our database, the hash is going to be completely different. There's no way for an attacker to know that these two passwords are identical. And this gives our hackers a much bigger challenge to go and get the decrypted password from our database. And it's going to take a lot of time and CPU power to work out what this password actually is. I'm not saying it's impossible, because nothing is impossible. Given enough time, given the correct tools, given enough computing power, then for sure, eventually these passwords would be able to be decrypted, but it gives you time to notify your users that if you had a compromise and your database was compromised, then it gives you time to notify the users that they need to change their password. Obviously, if you've got your application or database compromised, you're not in a good place. But it's not a complete disaster because you're not storing the passwords in clear text and you have time to notify the users to go ahead and update their passwords. It's especially problematic when users use the same email address and password in many different websites, because then if you compromise one email and password, then obviously the hackers would try and use that same combination in other websites as well. But what we're doing here is making it difficult for the hacker to work out what the password is for each user, and they'd certainly need to do the same process for each individual user. They wouldn't be able to work out that Bob and Sally have got the same password just by looking at the password hash. So when it comes to salting our password, the identity system uses a password hasher, and it iterates over the salt 10,000 times. So that makes it an order of magnitude more difficult to go and get the unencrypted version of the password. So you can consider this safe enough for our type of application. I'm not saying you would want to store people's credit cards using this kind of system, because that would never pass the security tests that you need to pass to be able to store that kind of information. But for the sake of usernames and passwords, this is adequate. So how does authentication fit into the clean architecture principles that we're going for in our course? Well, we're going to have a new entity in our domain model, and that's going to be our user entity. But what about our use cases? Is logging in and registering a use case? Well, yes, it is a use case. Our application requires users to be able to log in and register to our application. But when it comes to authenticating a user, then that's not part of our application logic. That's outside of our use cases. That's the responsibility of our API project. And the issuing of tokens and the authentication of those tokens is down to the API. Now, for practical and pragmatic reasons, I'm going to consider the identity system that we're implementing as a separate thing. Our application layer will have no knowledge of identity. It will have knowledge of the entity that we're adding for the user, but it will not know if that user's been authenticated or not. It's not its job. Its job is to process the business logic currently to retrieve activities and pass them out, or updates or delete, etc. So in our application, we're going to treat identity as a separate system, but still integrate it into our application. Our application layer will be able to get the user's username, and we'll be creating something to enable us to do that later on. But it's not going to have any knowledge about our identity system. So let's take a look at the before and after of what we're trying to achieve here. And currently we're not doing anything with authentication. If I'm logged in anonymously, or I don't have a token, and I click send, then I can go and get the activities. That's what we expect. But after we've implemented identity, then if we try and get an activity just as we were before, and I click on send, then we're going to get a 401 unauthorized, because we're not going to be allowed to get our data without first authenticating to the server. And the way that we authenticate to the server is we send up an authorization header which contains the token that we're going to issue to our clients. And then when they send up this particular header, then they'll get the activity because they have authenticated to the server. And we're going to be implementing a login and registration system as well, so that we can create new users and we can log in those users after they have registered. And also check that they can't add a duplicate email, of course, as we can see from this request. So that's what's coming up in this section.